Hello, welcome. Can you hear me?
Yes, I'm hearing you.
Yeah, how are you?
I'm good. How are you, sir?
Yeah, I am fine, thank you.
Yes, sir. I was too busy with examination.
Okay, no problem. We continue from the class. If
Yes.
topic is not completed, then we try to discuss about this topic for today's session.
Yes.
Okay, so let me share my screen. Okay, can you see my screen?
Yes, it is coming.
Is it visible now?
Yeah.
So let's continue. Yeah, so this is the topic. Yeah, so let's continue. Can you see my slide?
Yes, I see. That's right.
Okay. Okay, so basically today's session I discuss about that squatted settlement upgrading and GIS based mapping. Okay, this topic I try to complete all of example regarding this topic and how we can easily use the GIS and remote sensing for that squatter settlement upgrading and also GIS mapping. I hope you can easily get that all of idea and further you can also apply this type of idea for your work. So first of all, this is the topic: squatter settlement upgrading and GIS-based mapping. How we can easily do using GIS and remote sensing. We can easily use the different types of software like as ArcMap, QGIS. We can also use the different types of Python library. So I will try to explain all of details. Then I can easily get the idea about that squatter settlement upgrading and also GIS-based mapping. So first of all, introduction to squatter settlements. So basically unplanned informal housing area that develop without official approval. And its characteristics mainly lack of legal land cleansure and poor infrastructure such as road, drainage, electricity, water supply, and also it have high population density and also high vulnerability to disaster. So this is the common characteristics of squatter settlement, and the common challenges is that land tenure insecurity, then poor sanitation and health risks, also for low economic opportunities, and also lack of basic social services. And why upgrade squatter settlement? Basically, social and economic benefit. When you are applying the upgrade squatter settlement, first of all, we find out that social and economic benefit, such as improve the living standards, access to education or health service, economic opportunity, and for residents, as well as we find out the health and environmental improvement, such as better waste management, then reduce risks of diseases outbreaks, improve the water and sanitation infrastructure, as also legal and policy framework for upgrading, such as government-led housing policies, land tenure regularization program, community participation in planning. Okay, this type of things is for important for the upgrade squatter settlement. So role of GIS in squatter settlement mapping. So we can do there are a lot of role. Okay, such as spatial data collection analysis. Suppose you can easily collect the data, identifying the settlement location and boundaries. Okay, physically assessing the environmental risks and hazard. Then we also do monitoring settlement expansion or enforcement. We also do tracking the growth trend how using satellite imagery, and detecting the illegal land occupation we also identify using satellite or remote sensing also, as well as also assessing the infrastructure and service gap, such as mapping access to water, sanitation, road, and electricity, identifying areas needing the urgent intervention. We also do using the GIS in squatter settlement, as well as you can also do different types of mapping, such as this type of software we can use, such as QGIS software or ArcGIS software, also Google Earth Engine, or also use different types of Python library is also possible to use this type of work, as well as you can also data source for mapping, so you can easily use the different types of satellite imagery, Landsat, Sentinel, or any high resolution satellite imagery. You can also take the census data or socio-economic data, okay, physical data or field survey data you can also use to this type of mapping, and also basic spatial analysis techniques such as digitizing, okay, just digitizing the settlement boundary, overlaying the infrastructure data, and then check the GIS mapping for squatter settlement. Or intermediate level, we use this type of things such as land use land cover classification for informal settlement, okay, so we can easily identify different land uses such as residential area, commercial area, open space, using the supervised and unsupervised classification method it also possible. We can also do the network analysis for service accessibility, okay, so mapping the road network or transportation route, also measuring the distance to essential services, suppose school, hospital, market, and change detection analysis, so comparing the historical and current satellite imagery. You can also make the change detection, how much informal settlement increase, how much formal settlement increase, identifying the expansion over a period of time, suppose urban expansion or urban sprawl. So this type of things is also possible to use the GIS for this type of work. And advanced GIS and remote sensing upgrading we also use for machine learning for informal settlement detection. So random forest, support vector machine, or deep learning. Also use the automated extraction of settlement boundaries. Also use the LiDAR, so it's very advanced. We also use LiDAR or UAV application for detailed mapping, such as high resolution elevation data for infrastructure planning, or also 3D modeling for settlement area. So we can also use the LiDAR data or UVA data, UV application for detailed mapping, this type of work. And also policy driving spatial modeling such as MCDA mainly multi-criteria decision analysis for planning intervention, and also identifying the priority area for upgrading based on risks and need. Okay, so we also do is this type of things. So based on the MCDA. So this type of things we also use for this topic, and also I will try to show this type of example how we can work with that. Okay, so here use are the different types of software such as ArcMap or QGIS software. We also use the Google Earth Engine. Sometimes we also use for different types of Python library to work this type of things. Okay,
Sir,
yeah, please.
is it possible to use Python library without any other, without you can use a particular specific library without using a
Yes,
other software in Python?
yeah, it also possible. So suppose for this topic you can see when you work with um, network analysis, okay, for service accessibility, then we can easily use here
Yes.
the different types of Python library, and we can easily call the mainly your road network data or road data. Then it simply identify the measuring the distance or short path, or also make the mapping the road network, and also transportation route. So it also possible. And you already know about the land use land cover classification, okay, how we can easily use the machine learning and also create. You can also apply the supervised, unsupervised, then you can easily do. I think this topic you already know about that land use land cover classification. So I hope now I will try to
Yes.
discuss about the
Yes.
network analysis using Python environment, how we can easily collect the data, maybe road data, and further we can easily identify for the transportation route or measuring the distance to essential services route. This type of thing I try to explain it also more better. And change detection, I hope you already know about that, how we can easily make the change detection, and also how we can easily create the urban
Yes.
expansion map or urban spiral map. So it's very easy. Okay, I think this second topic is very important. It's not completed. I also discuss about that, as well as from
Yeah.
here support bit. You already know about that. So basically LiDAR data, we have another online training program. It's very high resolution elevation data for different types of work. We can easily do the LiDAR data, such as 3D modeling for settlement area. Not only for the settlement, there are a lot of uses for the LiDAR data for the different sector. Okay, so let's go try to discuss about this topic, network analysis for service accessibility. So mapping road network and transportation route, or also measuring the
Sir,
distance to essential services. Yes, please. Yes, you.
LiDAR data, LiDAR data, we didn't use LiDAR data since we started using the Google thing. Didn't you started our training?
Okay, so in this time, LiDAR data, I am not involved in this time because LiDAR is also high, some advanced online training program we have for that LiDAR. So then you can easily get this
Uh,
type of, for the LiDAR, we need to use the another software. Okay, so in this time, we are not use the QGIS or ArcMap or Google Earth Engine. We try to use the other types of software for handling the LiDAR data. Okay, as well as it also possible, we can also use the Python library. Some also R library is also possible. Okay, so Python and R, we are also handling the LiDAR data also, and we can do different types of analysis. Okay, so let's go try to discuss about the
okay.
network analysis for service accessibility.
Okay.
So now if you want, you can use at the Google Colab, or if you want, you can also use at the Jupyter Notebook. So both are the same process. I think Google Colab is more better to use because it's the cloud IDE. So let's go. Let me open my Google Colab. So just simply open a Google Colab. Just simply search here. Let me open a new notebook.
Can you increase the font size a little bit?
Okay, just a minute. So let me increase the font size. Yeah, so now it's okay.
Yes.
Okay, so first of all, we need to import some library. Okay, such as first of all, OpenStreetMap. Okay, we need the OpenStreetMap. Okay, so just we try to install a library. So just pip install. Sometimes this type of library default install it, but it also better we try to install again. Suppose OSM NX. Okay, also need to install suppose network X. Also install matplotlib is already installed, so just I simply installed OSMNX and also network X. So these two libraries, simply install it. So write the name and then click the run.
Sir,
Yes, please.
I sometime there is I think a lose in network. Sometime I don't hear well your words, but let's
Then pip install.
continue. Let's continue. I think my network has a problem.
Okay, can you hear me now? Hello. Okay, can you hear me?
Network. You.
Hello. Hello.
But hello, sir. I'm hearing you.
Okay, okay, so let's continue. Yeah. Okay, so just simply install the two packages. Okay, just simply install. So let's go and try to write the code. So now if you check the such import after install, just simply import. Suppose in this case I need to import OSM. Okay, also import the network KX. Also import the another library which is matplotlib as a pyplot. Just simply import all of necessary library. Okay, it's also done. So now if you want to check the version, suppose OSMX version you want to check or any other version. So for that just use here the OX and then put this symbol right here version. So just run the code. So this is the version, latest version about the OSMX, basically OpenStreetMap NX. We find out the version. Okay. So now after that, we need to choose a place. Okay.
Sir.
Yeah, please.
Hello, sir.
Yeah, yeah. Yeah, can you hear me? Okay, can you hear me? Hello. Can you hear me? Hello.
Hello, sir.
Yeah, can you hear me now? Yeah. Can you hear me? Hello. Hello.
Hello, sir. Hello, sir.
Yeah, I am hear you. I can hear you. I can hear you.
Yes, the issue of network.
Okay, so now it's okay.
Yes, now it is okay. I'm just hearing you and I see the screen.
Okay, can you see my screen also? Yeah.
Yes.
Okay. So let's continue. Okay, so just we try to check the version. So this is the latest version of OSMNX. After that, we need to take a variable.
So, sorry, sir. Can you start afresh? Explain the code a little bit from the installation.
Okay.
We
So
install the.
yeah, so just
Yes.
we install the two packages. First package is the
Yeah.
OSMNX. Another package is called the
Mhm.
Network KX. Okay, Network X. We try to install the two packages. Okay, just use the pip and then install these two packages. Okay, then we need to import the OSMNX. We just rename it as a OX, and also Network X. We rename it as a NX. And further, we also try to apply here matplotlib.pyplot and give the name as a PLT. Okay. Further, we also check about the version. So we check this is the latest version about that OSMNX. Okay. So now we need to define a place. Basically, which place you want to work in this case. Suppose I want to work for Dhaka Metropolitan. So I simply write my place. Suppose Dhaka Metro Metropolitan. Dhaka Metropolitan, then push and then comma, then put here the district name Dhaka, and also put here it's a Bangladesh. Okay, just use this way. Suppose this is the Dhaka Metropolitan, then put the district name and put the country name. Okay, suppose this is the local region, then this is the district name and this is the country name. Okay, just put when you put your
So
own
here you
study.
can put.
Yeah.
I can put your name here in the
Yeah,
place.
yeah, yeah, yeah,
Maybe
yeah, yeah,
my.
yeah, yeah. First of all, you simply check the name
Okay.
in here. Suppose I simply check here, this name is accurate or not, or Dhaka Metropolitan. Simply search. You can see the also can you can this is the address about that Dhaka Metropolitan Police Area or Dhaka Metropolitan. So try to use this type of address or this type of location, because in this case this it's come from the OpenStreetMap for your study area.
Okay.
Okay,
Okay.
just you can click on here, then we can easily get that more address. You can see Dhaka Metropolitan Puran Palton Dhaka. So this is the another address. So just use this, then we can easily find out this place. All of OpenStreetMap, not only for the OpenStreet, all of suppose when you work with the road or major road, minor road, everything we can easily find out from here. Okay, so let's go. Okay, just I put this type of name. It's not name. And further just run the code. So it's also okay, there is no problem. And we just stored the name in this variable. So now we just try to display this road network. So further just take a variable. Suppose I put the variable name is G, and basically it's come from the OpenStreetMap NX. So just call the OX. Okay, just call the OX because I rename it. Okay, after that just use a function. It's called the graph from place. Okay, you can say graph from address, graph from box, graph from place. I want to use the graph from place because in this case I already mentioned about the place address. Okay, so then just call the place. I already defined the place. You can see this is my study area, this I want to work. Just I copy and paste here. So this is the place. And then also mention about that network type. So just I put here the network type. I put here network type right. Right. So now just run the code. So now it will be downloaded. Okay. So for my place, Dhaka Metropolitan place, it will be downloaded. Network type, mainly driving network type. We find out in here. Okay. Road network. It also depend on your study area. When you work with big study area, it take more time. And also depend on the network connection.
Sadaka Metropolitan is the name of the road, is it?
Yes, so this is the address. Okay.
Address of the street or the road?
Yes.
Dhaka Metropolitan.
Yeah.
That is the road, is it?
So it covered the full Dhaka metropolitan area. Okay.
Okay.
Okay, it's done. So now we try to display. Okay, just try to display what types of network we find out. So for that, just I take a figure, just put at the fig, and then use at the ax equal, just call the ox, because ox basically it's the open street. We try to use this function. So we use this function to get the data. So now we are also called the ox, it's my library, osmnx library. Now I want to plot. Okay, just use at the plot graph. You can see the plot graph, plot footprint, plot figure ground. Okay, so I want to use the plot graph. Okay, and I want to plot the graph for this G who is downloaded my network. Just copy the G and paste here. So just run the code. Now let's check what happened. Okay, so we find out this type of, we can see, but we also try to use the different types of symbology and it's look more better. So now it display this type of things. We find out the road node. Okay, this is the node. Also find out that network. Okay, for our study area Dhaka metropolitan. So let's see, we try to modify, and for this visualization, so first of all, if you want, you can simply change the background color. It show as a black color. I want to change it. So for that, just use at the color. BG color I put in here. Oh, sorry, it's not BG color. And then I want to show it as a uh, suppose white color. I think it look more better. Just put at the BG color as a white. So now run the code and check what happened. Mainly background color. Okay, it look like that. You can see we find out the white color background, and I also change the suppose note color. I also change it. So just put here note, sorry, note color. Just mention this argument, note color. I put it note color suppose as a suppose red color. You can put any color. I put the red note color. So now run the code. Okay, so now display this type of note color as a red color. We find out, and if you want, you can also decrease the note size. Okay, suppose in this case we try to put the note size as a 1 pixel or less than 1. So just use here node size. I put the 1. Okay, then click the run. Okay, so now I think it also decreased, so we can easily find out all of road from here. Okay, and if you want, you can also use here the S color. Okay, suppose it show this type of gray color, so I want to use here, suppose S color is another color, so just put here that S color. I mentioned the color, suppose blue color. Okay, just run the code. Okay, so now I think it look more better. So from here you can easily get this type of node and also this type of edge we also find out in here. Okay. So now we find out this type of road. Okay. Now I want to calculate the shortest service. Okay. Suppose any location. Suppose I have a two distance. Suppose from my home to hospital, from home to um, school or university. So any location we simply choose, and further we try to identify for shortest path from here. Okay, so for that you need the latitude and longitude value. Okay, suppose from this point what is the shortest path. Okay, what is the shortest route, we can easily find out the shortest route from these things. Okay, so let's go, we try to identify this type of things. So further we need the two latitude longitude value. Okay, suppose from this point to from this point what is the shortest path. Okay, we also identify this type of things also from here. So for that, just take a new cell, and first of all, just take a value, take a variable. Suppose start point. Okay, and now define the latitude and longitude value in here. So you can put a specific geolocation. Okay, suppose for your hospital, for your specific any types of location, simply put in here. Okay, suppose in this case we try to identify, you can also find out suppose geojson. From here you can also
Sir,
get, yeah, please.
that, that, that is that point.
Yeah, a start point and end
Start
point.
point.
Yeah, yeah, yeah.
I can put any variable,
Yeah,
it
any
must be
value,
start point.
any value, it can be
Uh,
any
uh,
latitude longitude value, just put in here.
okay, okay.
Suppose I simply choose from here some latitude longitude value for the Dhaka metropolitan. Suppose for this study area,
You are searching on Google.
yeah, simply go to the this type of thing, you can easily get it. Okay, let me open the from, just remove the previous one. I just open, just run it, and now simply search here. That was Dhaka. So this is the study area of Dhaka metropolitan area. So from here you can easily find out all of things, all of feature. What you can see, Bangladesh Eye Hospital or family dentist. So different types of urban health center. So different types of things we can easily get, subslevate. Okay, so different types we can easily find out from here. Suppose now I want to identify from this urban health center what is the shortest distance from this place. Okay, we want to identify this type of things, or this is the from this university what is the shortest distance. So for that I need this latitude value, just click on here and then click. So you can easily find out, you can see the coordinate. So this
Sir,
value just simply use.
sir,
Yeah, please.
I don't see the thing that you are talking. I don't see. I see the map only.
Can you see the
Oh,
geolocation?
now I see the image on.
Yeah, yeah. So just we
I
take
think
a, okay, now can you
it
see?
was loading very slow. Now I can see.
Okay, I think some networking issue. Yeah.
Yes, now I can see. You can continue.
Okay, so just I copy, and now put here the lat value and longitude value. Okay, just I put the default and then I simply change the value. So for my case, this is my value. So this is the longitude value. Just I copy and then paste here. It's a longitude, and this value for latitude. Just I copy and paste here. Okay. So this is my start point. So same as just we take that in point, basically last destination. Just I copy the same and then paste and put the variable name, suppose in point. Okay. So just put here the in point. In point. Okay. So now
Start
we
point you
define the
and
another
then
point. Suppose I want to define this area or this mothizil. This area I want to identify from here. Just for that, just same process. Just click on here and then click on this place. So you find out this type of value. Just I copy. So now from this point and another point, you can see this point. Okay, so between this point I want to identify for shortest path. Okay, which is the shortest distance I want to identify using this node network analysis. So I simply put these two things. So just I copy. Yes, this is the longitude. Just copy and this value just simply put in here. It's a longitude value for my in point and also latitude value. So this is the latitude value for my in point. Just I copy. Just copy. And just we define this 2 point. Okay, so when you work with any point, we can simply mention the basically latitude, longitude value we need. Just run the code. So it also okay. We define the latitude, longitude value. So after that, after creating this type of start point and end point, so now we identify for shortest path. Okay. So now for that we need to make the node. Okay. Suppose for this point, using this coordinate and also using this coordinate, we need to create the node. Okay. Distance nearest node we need to create. So for that, again take a variable. Suppose start node and then define the we find out that ox dot get nearest or distance nearest that we use in here and start point and in node. Okay, just I put the default and now modified. So just I call the ox. Okay, from the ox we just input the distance ox dot distance distance dot nearest node. Okay, just call the nearest node we define. So just ox. Okay, ox we already defined the ox. What is the ox? You can see ox basically it's our osmnx, this library. So just call the ox and apply the function distance nearest nodes, define it. And now we define the start point. Okay, so in this port we just put the start point. We already defined the start point. So from the start point we also mention, suppose start point we mention the latitude and longitude. So basically just use here this square bracket and put here the 1 and also put the comma sign and call the start point. Sorry. Just define the start point and also mention here that 0. Okay, so basically you can see it's work as a dictionary. Okay, so we just take the 1 and 0. Okay, just we take the latitude and longitude value and mention in here. Same process also apply in here. Just I copy the same code and then paste here just change the variable. In this time we just need for the in point, just a copy in point and mention in here in point, also mention in here in point. And G, it's our full, basically this is the full OpenStreetMap in Dhaka Metropolitan. Okay, so now also put here that same function you also put in here. So just run the code and check what happened. Okay, it show you one problem. We find out that it show that point. Okay, it show the trans extra distance. Okay, we have to. Okay, without,
Zero. This is zero.
yeah, suppose without dictionary, what happened? Suppose I just mention. So I just put the make a list. Okay, we have to make the list, not dictionary. Just make a list. Okay, and store it the latitude longitude value. Then let's check what happened. And from the list we just take the 1 and 0 value. Okay, 1 mainly longitude, 0 mainly latitude value. We are just take. So now run the code again and also run it. Okay, so now it's okay. Okay, so without dictionary we are just take the square bracket and make the list. Okay, so from the list we are just call this type of things. Okay, so now we make the node, start node, and in node we just make in here. So now we just make the analysis. Suppose I want to identify between these two nodes. So you can see what is the step. First step, we need to create the start point and end point. Then we need to make the node, start node and end node. After that, we are just call the network X, this library. Okay, network X, this library. So for using this library, we are just calculate the shortest path, network X library. So let's go try to use it for network X, and then what happened we try to check. So for that we just take a variable, suppose shortest path. Just use this variable. You can put in any variable. Shortest path. So now here just call the nx. Basically nx is stored the network X library. Okay. So and apply this shortest path function and call the shortest path between that in node, start node and in node, between this node. And also if you want you can also mention here the width, suppose comma sign, and mention here suppose width. Width, just I put here the length. So now let's check the run the code. Okay, it's also okay. And finally we just draw. Okay, draw, mainly we try to make a plot. So for that just use the pig and ax equal, just call the ox dot plot graph root. Okay, plot graph root, we try to identify. And now put here G and call this shortest path. We already created, just copy and paste. And also okay, just let me check on the code what happened. Okay, we find out this type of things. Okay, but okay, it also create this type of, we can see shortest path we also find out in here. From this place to from this place we find out. So further you also modify this type of things. Suppose I put here root line width, root line width. Suppose I put the root line width, no, just a minute. Root line width, root line I put the 4. Okay, 4 pixel I try to put in. And also mention suppose node size node size. Suppose node size equal to, I put here suppose 5 pixel. And then you can also mention the busy color. Suppose background color, busy color equal white. And also mention suppose node color, node color equal red. Now let's check what happened. How we find out this type of things, but it not display our shortest path. Okay, so let me check.
I I don't see our shortest path.
Can you see my screen?
Yes, I see the screen, but I see only the red notes.
A minute. Okay, so now it also visible. As you
Okay.
can see, we find out this shortest path from this point to from this point. Okay,
Sir,
yeah, please.
in that shortest route that we have found, we didn't consider any impedance. Maybe to the distance, the speed, the traffic jam, or
Yes.
the any impedance that will restrict our movement. We didn't consider, is it?
Yeah, it also possible. Yes, it's yes, this one. Okay, this one is mainly distance. Okay, so in this time, suppose that for this place
Okay.
we go to the different path, different route we can use. But this route, when you use this route, will be shortest path from the distance. Okay, this is the short distance
Okay.
from this point to from this point. But if you
Okay.
want, you can also add different types of suppose traffic jam. So then we need to use some live, basically live API to identify for traffic jam or other things. It also possible, but further you also need to add the
What?
more advanced library for the Python. Suppose this place now
Okay.
traffic jam, so now it automatically show you this place is shortest path now, because it's also lengthy place. Okay, it take the more time from this place to from this place, it take the more time. And also suppose from this place it take the more cost. Okay, because this is the lot of traffic jam, so then we try to choose the another place.
Mm.
So this type of things is very advanced, okay, for that networking analysis. So it also very lot of things we can also do using this type of library.
Okay. Okay.
Okay.
Thank you.
Okay. Okay, so basically this is the way we can use the network analysis in Python. Can be performed using the library network X and also use the OSMNX, these two library. Not only for the two, there are a lot of things we can do. Such as you can easily identify, suppose network analysis or also shortest path, as well as you can also create the community detection. Okay, finding the group within the network visualization, mainly graph layout or plotting. Okay, suppose let me show you the another example. Suppose basic how we can easily make the plot. Okay, so let's go. So and I
We can
want to,
you,
yeah,
sir.
yeah, please.
Be, before we can export our map and the prepare layout using the maybe ArcGIS. This one we can display. We can
Yeah,
export.
yes. So this type of network as a vector, because it's a vector, basically it's a line. So this type of line you can also
Mm.
export as a polygon or vector data. And further we can also use the arc map for creating the map. Okay, as well as if you want, you can also
Okay.
add the title or also add the legend or other things we can also use, and then also represent this type of things. So let's take the another example, then it will be more better. So let's go. So
Yes.
now suppose I want to create, okay, let me just open the code cell. Okay, we already import the network X. Okay, suppose just import, already import, I again import, it not need. Okay, just import suppose network network X, this library, and I'll put the short name, suppose as a nx. Okay, you can put any name, and then also import matplotlib as plt. Okay, just I already import. You can import for your you can easily identify. So now create a graph. Okay, suppose I just take a variable g, and then I call the nx and apply a graph function ps. Okay, nx, and sorry, g is uppercase, g r a p s. Okay, just I put the graph. I take a variable g and put the graph. So it also take the graph. Okay, in this case I am not mention any types of a specific place. So now from this graph I add some node. Okay, node mainly this type of node. So it's one kind of node. It also another kinds of node. So if you want, you can also add the node default. Suppose I add the some default node. So for that, just I call the g. So it will store my graph. So just I want to add as from, suppose I put some value, just I make a list, suppose my node 1, suppose 1 comma 2. So it's one kind of node, and okay, we have to make the this, so it's one kind of node. Okay, suppose then this is another node, one, suppose x and y, suppose this is the y value, this is the x value. Okay, so x and y graph.
Yes.
Okay, and I put the another node, suppose 1 comma 3. I put the randomly, suppose put the another one, 2 comma 3. Okay, so just put the x and y value, put in here. So it's one kind of latitude longitude value we consider. So when you want rather real project or real street map, 2 comma 3, suppose then 3 comma 4, 3 comma 4, I take the another node, then suppose I put here, suppose 4 comma 5. Okay, suppose 4 comma 5. Okay, so this is the from the this graph I want to add the s, this type of s, 1 2 1 3 2 3 3 4 4 5. Okay, so just run the code. Also there is no problem. So now we calculate, suppose compute the, suppose centrally measurement. Suppose for this node I have total 1 2 3 4 5. From this 5 node I want to calculate, suppose center. I want to identify, suppose centrality measurement, compute the centrality between this 5 node. Okay, so for that just use a function. Suppose I take a variable, suppose degree or centrality equal, just call the nx, just call the nx and call the degree centrality, this function we have to use, and call the g. Okay, which is stored the graph. Okay, just run the code. After that, just we call here, suppose another function betweenness centrality. So just use, take a variable, suppose I put the variable name, suppose b2 ness centrality, sorry, equal, just call the nx betweenness centrality, just click to the run, and now we try to print. Suppose just I print this variable and then run it. So we find out this type of things. Here you can see degree centrality 0.5, then 0.5, then 0.75, then 0.5, 0.25 we find out. As well as if we want to check it, suppose print betweenness centrality, so we find out this type of betweenness centrality. Okay, 0.001. So these things you can also use a plot and also display. Suppose let's go try to create a plot. So for that, just call the plt function. We already defined the plt function. So just I put here plt dot figure and also define the fig size and then call the nx draw and finally plt show. Okay, so we set the width level true, we open the level and also note color. So we can put any, I put the sky blue in here, font weight just put the below. Okay, so let me show the result first just on the code. So we find out, we can see this type of things. Okay, so we find out, you can see this is the 1 2 3 4 5. Okay, this 5 node we generate. So if you want, you also try to put here, suppose node color, different types of color you can also put, and also edge color you can also define. Suppose I put here edge color, edge color equal, suppose I put here as a gray color, gray, and also increase the node size. Suppose I mention here the node size equal suppose 700 just on the code. So now you find out, you can see this type of things. Okay, so 1 2 3 4 5, total 5 node we find out in here. Okay, so yeah, you can see which one is, we find out the from this node 2 and 3 is very near, and also you can see 5 is very far from the 1. Okay, so this type of, so this in, it's a example, but when you work with the real project, then we need to create the node. And how we can easily create the node, you can see, suppose you can see for this example, just we input our study area. Okay, suppose I want to make the lot of things. Suppose at the same time I want to consider, suppose this is my home. Suppose you can see, suppose this one is my home. 2 is for suppose hospital, 3 is for suppose university, 4 is for suppose university or other types of feature or other types of node. So just we create the node, and further we can easily identify from our real map. Okay, so for that we need to convert. So we simply put here this type of point, start point in point, and create the node. You can see this is the one node, this is the another node, we need to create the node. After that we can easily you apply this type of degree centrality or other thing, we can easily identify from here for the real project when you apply. Okay, yes, as well as we can also use the social network analysis, suppose finding the influencer communities or relationship in the social media data, also transportation or road network analysis, uh, or, traffic flow or accessibility. Okay, so this type of things we also use uh, for using this type of python library. So now we try to download the data. Okay, how we can download this type of data. Okay, so for downloading the network data as a vector, typically we can means exporting, how we can easily export like a GeoJSON, shapefile, or also network X, GeoPandas. This type of thing we can easily export. Okay, so let's go and try to export the file. So for that, we need to import a library. It's called the GeoPandas. Okay, so let's go and try to do it. Example, just import a library. It's called the GeoPandas. Pandas. As suppose GPD. I put the name GPD, GeoPandas. And also we also need to work with the Shapely. Suppose I put the Shapely dot geometry. In this time we import here the line string because it's a line. So put here the line string. Just run it. So it's also okay. So now we need to road network with a special condition. Okay, suppose we create the edge. So if you want, you can also use it. Suppose take a variable edges and make a list. So in this list, we need to define or okay, let me check. Suppose I want to download this type of data in here, line string. So here we already work with is mainly shortest path we already downloaded. So this shortest path I want to download. Suppose this shortest path as a line string. So for that, okay, so let's go. We try to do it. So for that we need to convert. Okay, just as is already we downloaded. So let me write the code. Suppose convert to geodata frame. Okay. So for that, take a variable is GDF and we convert. So just call the is okay, but in this case our is it's come from this shortest path. Suppose this this shortest path, just copy and I want to mention in here shortest path. Okay, and then we define the geometry. It's not need, we try to remove it. Just I mention here geometry equal to is no geometry, basically you have to mention here geometry equal to geometry. It's a problem. It show the problem is that unknown column geometry. The geometry equal to shortest path. We try to check. Okay, so let me add the s. Suppose random is we try to create. Okay, so let's make a dictionary. In this dictionary, put here suppose I have a source. This is the keyword, and I put the key value suppose source 1. So this is my start point. Now I put here the source 1, target 2. So this is the source 1 from target 2 and this is the geometry. Suppose this is the 0 0. This is the one kind of node. 1 1, this is the another node. And for this same process source, and we define here the 2 to 3, target is a 3, and this is the 1 1 2 2. So we define the node in here as a line string. Or you can also add the more. Okay, so in this time we just use work for the 2 as okay, it show the problem. We need to close the bracket. Yeah, so now run the code. Yeah, so it create the as. Okay, so now you can see here this is the source. We need a source. Suppose from this is the source 1 to 2, then the source 2 to 3, and we create the line string. So this line string basically put the x and y, x and y value, x and y value, x and y value. So now these things we try to export. So just convert geodata frame, just call this as and define the geometry and call the geometry, okay, which stored the this type of line string. Just paste here. So run the code. Okay, so now it's okay. Okay, as well as we can also convert as a GeoJSON file. Suppose just take the new cell. So just call the, just I copy the same code and paste here. So GDP, or I can directly save it. Suppose just I remove this variable GDP. Just use a function. This function call that. Okay, just call this variable. This variable I want to download. Okay, so put here to file function, to file, and apply the GeoJSON file and the driver in the GeoJSON. So now run the code. Okay, so now it show this type of things. Not provided, the CRS was not approved. The output dataset will not be have projection information, because in this time we take the demo data enables in other system. Okay, so now try to check it. Yeah, you can see this is the GeoJSON file we downloaded. Okay, so this is the GeoJSON file we downloaded. Not only for the GeoJSON, if you want you can also download the shape file. Suppose, and this it's not, it's not the real data, so that's why it that its projection is not completed. Okay, CRS was not provided. So let's go try to apply, just call the s this variable. I want to download it. Just copy and paste here. So these things I want to download. So just put here the to file, and now download the shape file. So just simply change the extension. Suppose I want to put here extension is that ASP. Okay, okay, for that it's not need, just I know it's not need for the shape file, just you know. Okay, just run the code, it also okay. So further we also find out in here, just refresh. Yeah, so here you can see we find out the shape file SSP, SSX, PBF and CPZ from this file. So now what is the condition for when you work with that? So we need to create the line string. Okay, using the node, we need to create the line string. Further we can apply this column name. Okay, which column stored the mainly point line, mainly line for the line string. So then we mention in here. Okay, mention in here this column name as a geometry, it is a column name. So further just call the to file function. Basically it's come from the geopandas, GDP geopandas. Okay, then we are just simply mention the file name. You can put any file name and also put the extension GeoJSON or SSP, then it will download it. Okay, from here you can download the data and also work with dark map or QGIS software for prepare your map. Okay, okay, can you understand about that?
Yes, yes, sir. Yes,
Okay,
sir. I understand.
okay, so you also try to download it for your real data and then check what happened.
Yes.
Okay, so if you want you can also use here, suppose another way. So I'll show you that. Suppose we are using the different types of network type. Okay, suppose one network type is called only for that. uh, Suppose this is the drive is one kind of network type. Then walk, only for the walking street. Okay, then also for the bike, then also for suppose all is including everything. Okay, so different types of things we need to download it for the different types of purpose. So let's go. I to show you one
Yeah.
another example. Suppose I just simply import. We already import the OSM nx as ox. I put the again import, and then I want to download the data for a specific city. Okay. Okay, just a minute. Okay, so now let's go. We try to do it. So first of all, I simply define a place name. Suppose I want to work for the one state. Suppose San Francisco. Just I write the name Francisco, comma. It's mainly California. Just put here the California, near, and it's mainly country name mainly USA. Okay, just I put it San Francisco, California, USA, and then
Can
yeah,
okay.
just run the code. It also okay. And further we try to suppose download the data for state network as a graph. So for that, and just I take a variable g. You can put any variable name g equal. I just call the ox. Okay, ox basically open state data. We can just call ox dot graph. You can see here place name network type. So we can put here that drive only for the car driving, or also you can see the walk mainly uh, pedestrian path. Okay, pedestrian path, or bike mainly bicycle lane. Okay, bicycle lane, and also you can the all transport network. Okay, suppose in this time which one is you need, just simply put the name. Suppose I need for all, then put here that all. Okay, so now we downloaded all of transport network. Just run the code. So now we find out that San Francisco's in California, USA, we find out that all of networking transportation, okay, transport network, we find out. Okay, or if you need for a specific, then you can also try to apply for the specific walking road or bicycle lane or driving road, okay, or car driving. Mainly drive it's indicating about the car driving road. Okay, Okay, it working. It downloaded all of, okay, all transport network, including drive, walk, bicycle, and everything. When you put the all, okay, it's done. So now further, suppose you want to display, just apply the same process which I already show you. Suppose just I copy the same code from here, just I copy and then paste here. Okay, just I call the G and further I put the same as just run the code. Okay, so you find out, you can see this type of things. It is a San Francisco, all of road. We find out all of node on road. So now you try to check for shortest path. You already know about that. In this time I not show you that. Suppose I have to export all of road network from here, different types of uh, extension, GeoJSON or shapefile, these type of things. So just we convert the node and edge. So export the network as a GeoJSON or shapefile. So for that, convert the network to the geodata format. So this network we need to convert the geodata format. So we already import the geodata frame, geopandas library. So just I call the node and is equal, just I call the ox open street and apply a function graph to gdf, meaning gdfs, graph to gdfs, graph to gdfs. Just I put and run the code. So now node and s convert graph to GDFs, mainly geodata format. And when you find out the geodata frame, we can easily download. Okay, it can be GeoJSON or shapefile. You can easily download. So let's go try to download it. So for that, suppose just call the s, and this is I want to download, suppose shapefile. Just put here to file function, to file and import and put the, suppose I put here, just I put here the file name. I put the file name, suppose road network, node network, and also put the extension, suppose SSP. Okay, so now further just run the code. This file will be exported, whole file. Okay, export is as a shape file or GeoJSON, same process. Okay, so now I can see it will be done. And further, if you check the file from here, just click on the folder, we find, you can see the road. Okay, road network, all of extension SSP, SSP, PRG, DBF, CPG. So need downloaded the full road network for this San Francisco. Not only for that, when you download the GeoJSON, same process just apply. So just call the is and then just call the ox, this function library. From this library, okay, sorry, we have to is just put the to file. Okay, just we convert to file, just road network GeoJSON driver GeoJSON, just run the code. So now it will be downloaded as a GeoJSON file. Okay, so now let's check from it, just refresh it. Yeah, this one, just a download, suppose download. Okay, download it.
Sinani alichanua watu wa Mombasa wakaamua kuita Alikiba akuja wainterpretie vitu vinavyofanana na hivyo. Alikiba naye wakafanya branda ni wa kutoka Tanzania, nao ndio matadra wa Kiingereza. ingekuja interpret Goma. Wizkid akiba ile ngoma yake hayuko na dance. If I show you a money, alikipa kutu hapa. Mali ni nyingi nyumbani.
Further, this file you can also open in the GeoJSON. Okay, just you can see the open, and then choose your file, and then you also display the all of road network from the GeoJSON website also. I think also download it. It takes some time. Why? Okay, it's downloaded. Yeah, 21.3 MB. Okay, so huge file. Okay, so let's go try to import the file in here. Just okay, so let me open the new GeoJSON. Just I remove it and then run again. So now we find out that new feature. Click on the open and go to the download folder. What is the file name? Road. Yeah, so let me open it. Yeah, this one, road network GeoJSON. Just I open. So now it's uploading. Okay, I think some networking issue. Yeah. Or this file size is very big, so that's why it not loaded. So this GeoJSON you can also open in the QGIS software. You can also check all of things such as attribute table or other thing. You can easily check it from here. As well as you can also export. Okay, let me show you that. You also try to export it in the open it the QGIS software, ArcMap software. Then I hope it will work. There is no problem. Okay, so now we try to also export as the graph ML. Okay, for network X. Okay, for the graph ML, you can also use create the graph. Okay, I think it's a useful for future networking analysis in the network X. So just call the ox dot save graph ml. Okay, so now further call the g, it stored the full, and let's put the file path. I put the file path name. Basically I put here suppose this type of network graph ml. Just run the code. So now it will be save as a graph ml. Now refresh it and check the graph email. Okay, just let me download. As well as you can also geo package, you can also download, okay, jpkg format. And further you can also work with. And graph ml, basically it's need for that advanced network analysis. We can also use the graph ml format. Okay, it's working. Okay, it's done, so just let me open it. Okay, there is no application to set the open the document graph ml. Search the app store. Okay, so I think graph ml, this file is not in the Mac. App is not okay, so you also try to open it others windows, you also try. So I hope you can also get the graph ml format file, you can also open. Okay, and graph ml is very useful to for advanced network analysis. Mhm. So you also try this type of social network analysis, finding the influential people. It also important, such as centrality or betweenness centrality. So these type of things also useful. Identifying the influence in the social networking, as in road network analysis, finding the shortest path. We already know about that. As well as though suppose citation network. It's very important. Basically, academic paper influence. So these type of things you can also check it. Community detection, okay, detecting the groups in a social network, it also important. Or flight network, mainly airline route optimization, we also do it. For that airline route optimization, it also possible, such as New York to London, New York to Los Angeles. So different types of things you can also do it. It's identify mainly major airline hubs and optimization the flight route, we can also do it. Then also epidemic spread simulation or traffic flow analysis, mainly finding the bottleneckness. So these type of things also possible to work with that. So there's a lot of things we can also do for that networking analysis. So I hope you also try to use this type of things for your own study area. And further face any problem, then also let me know. I'll also guide you how we can easily work with. Uh-huh. Okay, and then other part, I hope you can know about this type of things, change detection for monitoring the growth, such as urban growth monitoring or formal informal settlement or land use land cover classification for informal settlement, or also identify the residential commercial open space. You already know about these type of things. Also you know about that digitizing. Okay, you can easily digitize your boundary. Suppose just open your just suppose Google Earth engine, just simply open the code editor. You can easily draw the different types of things, as well as you also get the building footprint data. Okay, it's also helpful to for this type of analysis, squatter settlement analysis. So you can simply digitize your study area. Just take the satellite and then simply zoom. So you can easily draw the different types of point line polygon from this high resolution imagery. Just digitize your study area, digitize your specific road, okay, or road line, also house. Okay, you can easily digitize from the satellite imagery from here. Further, you can easily download. Suppose I want to download this shape, okay, or I don't want to download this home space. So just simply click on here and then digitize your area of interest. Anything you can easily digitize. And further, it also help you to identify different types of things from your QGIS software, ArcMap software. Just digitize your area, and further this thing you can download as a shape file or KML file. I hope this type of things you already know how we can easily work. Suppose you can see it also show this type of car. But in the advanced AI, basically artificial neural network, we can easily detect, okay, this type of things. Suppose just apply the different types of convolution neural network, or also ultra YOLO v2 model. Then we can easily detect for a specific feature. Suppose I want to detect how much car in here, okay, how much car available, so it automatically detect all of car, and also counting how much number of car is available in here. So then further need to use the different types of deep learning. So it's a more advanced. We can also teach this type of training also for the deep learning. Then you can easily learn how to detect all of car, okay, also segment this type of building or rooftop, okay, or this type of house. So further we need to use the high resolution imagery and also apply the deep learning model to detect, or also segmentation, or also counting the number of trees, counting up cars. So these type of things we can also do it from using this type of advanced learning. Okay. Okay, can you hear me?
Yes, sir. Yes, sir.
Yeah,
I'm
yeah.
hearing you.
Okay, so I hope these things you also learn, this type of topic you also try to I hope you already know about that. So now I skip. So I also send this type of things. Further, if you face any problem, then you can also contact with me regarding this online training program. Okay.
Okay. Okay, sir. So,
Okay. Thank you.
but sir,
Yeah, please.
I sent you some. I've got some problem with my software.
Okay,
I
okay.
sent you
Kindly.
some problem. I
Okay,
think
kindly share the screen. Then it will be more
in
better.
WhatsApp.
Yeah, yeah. Kindly share the screen.
It it was in WhatsApp I sent you, but not in a screen.
Okay, so basically, I think
If
this
you can,
layer, this data is not available in your ArcMap. So that's why it create
yeah, they
this
were.
type of problem. Okay. Suppose this data is
Uh,
not saved in your ArcMap or QGIS software.
mm,
So that's why it show the error or unknown. So you mentioned just make sure that this data is saved in your local storage. Then you also try to use. Then I hope it will be work. There is no problem. Mhm. Sometime
okay,
this,
sir.
yeah, please.
Mm, yes. Sometime.
So sometime suppose this data is not available from your computer, but you save it. Suppose I send you a ArcMap file, okay, ArcMap file, but I don't send you the data. So that's why you find this type of
Mm,
problem. Okay, so there is no data. So you find out this type of red alert in the layer.
okay.
Okay. So you also try and make sure
Okay, sir.
that
But
data is
also,
available. Yeah, please.
I